In this lesson, we will study trigonometry. Trigonometry is the name given to the branch of mathematics that studies operations on angles and their applications. To motivate this idea, I have a triangle drawn here, and I want to ask this question. If you know the lengths of two sides of a right triangle, like maybe this side and this side, can you use this information to figure out the measure of the angles? Just so we have some numbers to work with, I'll call this side length 3, this side has length 4, and this side has length 5. Is this in fact a right triangle? We can use the Pythagorean theorem to answer this question. That is, does c squared equal a squared plus b squared for the numbers that I have listed over here, where c is the hypotenuse, and a and b can be either one of those numbers. To check this, I will put 5 in place of c, I'll put 3 in place of a, and 4 in place of b. Is this a true statement? On the left, 5 squared is 25. On the right, 3 squared is 9, and 4 squared is 16. And it works out. 9 plus 16 is in fact 25. Because this holds in this triangle, this is for sure a right triangle, and that's by the Pythagorean theorem. So now that we've settled that we do in fact have a right triangle, if this side is length 3 and this side is length 4, could you use this information to figure out the measure of this angle, which I think I'll label as angle A? Can we figure this out? I mean, it seems reasonable. If you go this distance and this distance, seems like you should be able to compute this number. In fact, this should be true for any two sides that you pick. If you know the length of this side and the length of this side, you probably could figure out this angle. And the same thing goes for this side and this side. That's probably enough information to figure out what the measure of this angle is. So the question is, how do you figure it out? I did a little work beforehand, and with my calculator, I was able to estimate that the measure of angle A, and this is a really good estimate, it's 53.14 degrees. And so I'll place that angle right here. That was 53.14. And since we know this angle and this angle, you could figure out this angle too. And you actually know everything about this triangle, the lengths of all the sides and the measure of all the angles. But the question is, how did I get this number by using my calculator? Well, on my calculator, there are 3 very important formulas. They are sine, cosine, and tangent. And they are actually abbreviated SIN, COS, and TAN. So these are formulas that you can plug numbers into and it will give you a number back. What I mean by that is if you push the sine button and then enter in a number like maybe, 75. So you enter in a number into this formula and your calculator will give you a number back. For 75, I got 0.9659, and it goes on, but that's the connection. You put a number into the formula, and then your calculator gives you this number back because it's programmed to do that for you. You can do this process for any one of these formulas. You can put any number that you'd like into either sine, cosine, or tangent, and your calculator will give you some information back. Now, that really doesn't tell us what sine, cosine, tangent are because that's not the definition. That's just how your calculator works. Let's go over how these 3 formulas are defined by going back to this right triangle. So as I said, if you know 2 sides of a right triangle, that should be enough information to figure out what the measure of an angle is equal to. So I'm going to introduce some definitions that connect any 2 sides to a given angle. If this is angle A, I'm going to call the side opposite the angle the opposite side, which I'll just abbreviate OPP for opposite. This is the hypotenuse because it's the longest side, so I'll abbreviate this side HYP for hypotenuse. And then, well, this side is adjacent to the angle in that it's connected to it. So is the hypotenuse, but this is the side adjacent that is not the hypotenuse. So I'll label this ADJ for adjacent. So to find the measure of this angle, we have to pick two sides and come up with some type of connection between them. So let's start with the opposite and the hypotenuse. The definition of sine, so you'd say sine of the angle A, by definition, we call that the ratio of the opposite side to the hypotenuse. So you'd actually take this side and divide by this one. You get a number, and we call that number sine of A. And you can also get that number by using your calculator. And your calculator is programmed to make these two things match. Other two sides. So we use the opposite and the hypotenuse. You could also use the adjacent and the hypotenuse to connect it to this angle. And that's what we call cosine. We would say that cosine of the angle A is the adjacent side divided by the hypotenuse. And there's one more possibility. You could use the opposite and the adjacent side, and that's how we define tangent of the angle A. It's the side opposite divided by the adjacent. So if you've ever heard SOHCAHTOA, if you've heard this, it's just a nice way to remember these definitions. Sine is the opposite over the hypotenuse. Sine, opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Tangent, opposite over adjacent. So if you want to commit these to memory, here's like a nice way to remember how to do that. Now, these are the definitions, but for this example, what are these actual fractions equal to? And that's very easy to figure out. So let's start with sine of A. Sine of the angle A is the opposite over the hypotenuse, and that's 4 divided by 5. So what is sine of A? It's 4/5. What is cosine of A? Okay, so that's the adjacent side 3 over the hypotenuse, which is 5. So as a fraction, that is 3/5. And likewise, what is tangent of A in this example? It is 4 divided by 3, the opposite over the adjacent. So that is 4/3. So that's quite a bit, but just to recap, in a right triangle, we can take any two sides and divide them, and that's what we call sine, cosine, and tangent. These are also formulas in your calculator that you can plug numbers into to get a number back. So what's the connection between the two? How was I able to figure out the measure of angle A by using this stuff? Well, the way I did it was, I picked one of these, and I chose this one here. I could have picked any of the three, but I just went with this one. 4/5, if you divide that into your calculator, this is the same thing as saying sine of the angle A is equal to 0.8. So from here, I just did a guess and check approach. I put numbers in place of A that made sense off of this diagram until I got something that was very close to 0.8. When I first looked at this triangle and I didn't know what the measure of this angle was, I guessed that it might be about 50 degrees. I knew it was greater than 45 because these two sides were almost equal. So I thought, okay, well, I'm just going to guess. Hey, maybe the number that makes this equation work is 50. And when I typed in sine of 50, I'll round to 2 decimal places, I got 0.77. And I was like, oh, that's pretty close. I mean, I just want to choose an angle until I don't see 0.77, I see 0.8. And then after a little bit of work, I typed in 53.14. So I'll do that again, sine of 53.14. And it wasn't perfect, but the number I got back was 0.8001. And in fact, if I round that to 2 decimal places, it was exactly this number. So I was like, okay, fantastic. I was able to get a very good estimate for what this angle is equal to. So all this being said, what are sine, cosine, and tangent? They are things programmed into your calculator based off ratios of sides of a right triangle that allow you to reason out what the measures of angles in the triangle are equal to. All right, so let's get some practice using these definitions in a few examples. In example 1, let's try to find the measure of angle A and at least get a good approximation for it if we can't find it exactly. As a reference from the previous slide, I'd like to draw the triangle that we were just working on, where we called this angle A, this side was 3, this was 4, and this was 5. It was in fact a right triangle, And I was able to reason out that the measure of angle A is equal to, I believe, 53.14 degrees, at least approximately. And we also used the fact that sine of the angle is defined to be the length of the opposite side divided by the hypotenuse. Can we do something similar here? Let's try it out. What I want to do is write down, for this triangle, what's the definition of sine, cosine, and tangent. I'll write down SOHCAHTOA so we can use that as a guide. Starting with sine, sine of this angle A is the opposite over the hypotenuse. So that is 8 over 10. Cosine of the angle is the adjacent side over the hypotenuse, so 6 over 10. These are all just by definition. And then tangent of the angle is the opposite over the adjacent. So that's 8 over 6. And that's it. To go from this information to figure out the measure of this angle is just a matter of picking any one of these three. I guess we could again just, look at sine of A. And then you want to put an angle measurement. Maybe probably something, again, close to 50 degrees seems reasonable. You want to put values in place of A so that you get a number back that's equal to 8 over 10. Okay, so I can take 8 over 10 and I can write that as a decimal. I think that'd be a little bit easier. So we're trying to guess, well, what angle would give us a decimal of 8 divided by 10 is 0.8? That's exactly what we had last time, right? I mean, if we look down at this triangle here, if we look at the opposite over the hypotenuse, that is sine of A is equal to 4 over 5. And if you divide those, you get 0.8 as well. That's the same number. That means the same angle is going to be what you enter in place of here to make this thing a true statement. In fact, I'll just state it again. Yeah, sine of 54.13 degrees gives me a value of 0.8 back in my calculator. So in this example, what's the measure of this angle A? Same thing. It's also 53.14 degrees. Is that a coincidence? No. These are actually similar triangles. In similar triangles, all of the corresponding angles are equal in measure. The sides are different, but the sides are proportional. I mean, look at this. If you go from 3 to 6, you've doubled it. 4 times 2 is 8. 5 times 2 is 10. They are in proportion with each other. Therefore, the corresponding angles are going to have equal measure too. So this one should be the same as this. An easy way to see that that would have happened is you can reduce these fractions. In this triangle, sine of A, it certainly is equal to 8 over 10, but you can cancel a factor of 2 from both of those. I mean, this is the same thing as sine of A is equal to, if you divide 8 by 2, you get 4, and if you divide 10 by 2, you get 5. So you actually get the same ratio that you get down here because you're canceling that common multiple of 2 that's increasing the sides. So likewise here, if you cancel a factor of 2, cosine of A is going to be 3/5. And for the last one, tangent of A is equal to 4/3. This reduces to the same problem that we were looking at in the previous slide. Sure, we doubled all the sides. That didn't change the measure of the angles. But the important thing is it matches up with the formulas that we have here. This is why we use ratios in defining sine, cosine, and tangent. It's so that we don't get different numbers when we're looking at similar triangles. All of those angles should in fact be the same. In example 2, given this triangle, let's find sine of A, cosine of A, and tangent of A in reduced form. So just to state those definitions, I'll write this as a reference. All right, let's start with sine of the angle A. So sine of A is the opposite over the hypotenuse. So we're coming up with a fraction. And this time, the side opposite is here, which is 60. So I'll call this the opposite side. And here, 87, well, that's the hypotenuse. And we can go right to this fraction and put 60 here and 87 here. So 60 and then 87. This seems like a reasonable answer, but it's also asking for it to be in reduced form, and I'm thinking there might be a common factor between 60 and 87. I know 3 goes into 60, it goes into the sum of the digits. If you add 8 and 7, that's 15, and that means 3 goes into this as well. We can cancel a 3 from both 60 and 87. So 60 divided by 3 is 20. So 60 divided by 3, and we'll take 87 and divide by 3. In doing so, sine of A is 60 divided by 3 was 20, and 3 goes into 87 twice, and then 9 times. So that's a remainder of 0, and this is 29. There are no common factors between 20 and 29, so here we go. This is the value of sine of A, the opposite over the hypotenuse. All right, now what about cosine of this? Cosine is the adjacent side over the hypotenuse, but there's no number listed for the adjacent side. How can we find the length of this missing side? Because this is a right triangle, we can use the Pythagorean Theorem, which states that a squared plus b squared is equal to c squared. C represents the length of the hypotenuse, and a and b are the lengths of these sides. I'll call this one b, meaning we're going to solve for a. I don't know this. I'll put 60 here and 87 here. So we get that a squared, which we don't know a, plus 60 squared is equal to 87 squared. I'm going to subtract 60 squared to the other side of this equation so I can have a squared by itself. So I'm subtracting 60 squared. We have that a squared is all alone on the left. The right is 87 squared minus 60 squared. I'm going to directly enter this into my calculator, and this is a squared is equal to, 87 squared minus 60 squared is 3,969. If I want a, and this is a squared, I can solve for a by taking the square root of both sides of this equation. A square root and a square are inverse operations. That's a fancy way of saying the left side is just going to be a all by itself. On the other side, I can actually type in square root 3, 9, then 6, then 9, and it actually came out to be a nice integer, which is 63. That is the length of this side here. This side has length 63. Now that we know the adjacent side to angle A, and that's what's in the definition of cosine, we can figure that out. What is cosine of A? It's 63, the adjacent, over 87, the hypotenuse. Again, I know 3 goes into 87, and 3 certainly goes into 63. Not 20 times, but one more time, 21 times. We can divide the top and the bottom by 3. And this gives us an answer for cosine. Cosine of A is really 21 over 29. That has no more common factors, and therefore this is the answer for cosine of angle A. Now, what is tangent? Tangent of angle A is the opposite, 60, over the adjacent, 63. That also is not reduced. We can divide both by 3. The top is 20 and the bottom is 21. That can't be reduced. In fact, tangent of A is equal to 20 divided by 21. All right, so on this right triangle, we actually found the values of sine, cosine, and tangent of angle A. In example 3, I'd like to find the measures of the parts of this right triangle that are not given. So that is the measure of side A and C, as well as the measure of angle B. I think with the way this is set up, we could find any one of these first, so I'll choose side A. To do this, we want to use either sine, cosine, or tangent. Note that in this mnemonic, we're using the letter A to represent adjacent to the angle, and this letter A is some other variable that is representing the measure of this side. So let's be careful not to confuse these two different things in this process. That being said, if I want to solve for A, this angle is opposite, and this side is adjacent to this angle because it's not the hypotenuse. So I'm looking for an opposite, an O, and an adjacent A. Tangent is the one that has both of those things. So over here, I want to use tangent to solve for the measure of side A. The definition of tangent is tangent of the angle and its measure, that's 50 degrees, is equal to the measure of the opposite side, in this case it's called A, divided by the measure of the adjacent side, which is 16. So tangent of this angle is opposite divided by adjacent. In this equation, I know 16. Tangent of 50 is a number that you can get off a calculator, so this is known as well. The only thing we don't know is A, and that means we can solve for it. I'm going to multiply both sides by 16 to get A by itself. So on the left, that is 16 times tangent of 50 degrees. On the right, I'll multiply by 16, I guess technically 16 over 1. The 16s cancel to give you 1. This entire side is just A, the thing that we're looking to solve for. On the left, we have 16 times tangent of 50 degrees. I can now type this into a calculator. My calculator is programmed to give me the correct number for tangent of 50. So 16 times tangent of 50, I'm going to round to the nearest whole number. I think that'll be a good enough approximation. I get 19 is equal to A. And that means that's the length or the measure of this side. This one's 16, that one's 19. Before moving on, I want to make a important note. If you're using your calculator and equations like tangent, sine, or cosine, you want to make sure your calculator is set up for degrees. So typically there's like a mode or a button that you can select. So you're using degrees because that's the unit of measurement here. There are other units used to measure angles. There's gradients, there's radians. They have different meanings. So just make sure that you're getting the same number as I am, and that's because my calculator is set to use degrees. That being said, I know the length of this side. What should we find next? The measure of angle B or the length of side C? I think I'll go with the length of side C. Because this is a right triangle, you could use the Pythagorean Theorem. This squared plus this squared is equal to this squared. You can also use these equations as well. So for some practice with these, I'm going to use either sine, cosine, or tangent to solve for C. There is more than one way to do this, but I'm going to use this angle, and I think I'll choose this side, the adjacent side, and this side, which is the hypotenuse. Because this is given information, it'll probably give us a more accurate answer because this one here was rounded. So I'm going to stick with the given information. I was given this, and I was given this, and I want to know this. The equation over here that has adjacent and hypotenuse, well, that's this one. That is cosine. Cosine is the adjacent side divided by the hypotenuse. Let's set up that equation next. So cosine of 50 degrees, this angle is this side divided by this side. So that is 16 divided by C. All right, so how do I solve this equation for C? I'm going to do a very similar process here. Here we multiply both sides by 16 to cancel it. Here, I don't know this, but I can still multiply both sides by C. So on the right, that is C, or if you'd like, C over 1. And then you're doing the same thing on the left, multiplying C to cosine. Again, some confusion can happen here because the letter C is used in cosine and C is representing this variable, so we'll just have to be careful here. On this side, C represents a number, and you can cancel it just like the 16s. So whatever that number is cancels with whatever that number is. This whole side is just the number 16. And on this side, well, I guess I'll write that as C multiplied to cosine of 50 degrees. We'd like to solve for C. It's not by itself because this is multiplied to it. I can divide this to the other side of the equation. So here I'm dividing by cosine of 50 degrees. That's a lot to divide by, but this just represents a single number. If you want to cancel it, you have to divide by the whole thing, and you have to do that to both sides. On the left, they cancel, and we're just left with c. So I'll put that over here. C is equal to 16 divided by cosine of 50 degrees. This is an expression I can type into my calculator, and I will round, I guess, to the nearest whole number again. So 16 divided by cosine of 50 degrees, I get 24.89, and that is 25 if I round to the nearest whole number. So that is the length of the hypotenuse, approximately 25. Again, we're rounding. There is one last piece of information to find, and that is, well, what is the measure of angle B? Well, I know that if I add these three angles together, it's equal to 180 degrees. So I could take 180, subtract 90, and subtract 50. Here's a nice shortcut. If this is a 90-degree angle, these two angles must add to 90 because 90 plus 90 is 180. So a faster approach to take is if you want to find this angle and this angle are complementary. They add to 90 degrees. So you could simply say, to find the measure of angle B, just take 90 and subtract 50 from it. That's faster. So 90 minus 50 is 40. In fact, 40 degrees. Note that 40 plus 50 is 90. 90 plus 90 is 180. And this is the measure of angle B. In example 4, let's look at an application of trigonometry. Suppose you're standing 350 feet from a building, and the angle of elevation, so that is from ground level to the top of the building, is 41 degrees. Can we use that information to determine the height of the building? And it's probably easier to measure this distance and this angle than it is to measure the height of a very tall object. Let's draw a picture for this. So here we are 350 feet from the building, and there's a 41-degree angle. So like if you were standing over here, the angle from ground level to the top of the building is 41 degrees. And here it hits the top of the building. And the building, if built properly, is perpendicular to the ground, which creates a right angle here. The height of the building is going to be the length or the measure of this side. And I'm going to call that x. That is the thing that we are solving for. So essentially, this problem turns into, on a triangle, if you know this side and you know this angle, can you solve for this side? And of course we can, now that we have defined sine, cosine, and tangent. We just have to use the appropriate equation. If this is my angle, this is opposite, so I'm either using sine or tangent. And this is the hypotenuse. It's opposite the right angle. It's the longest side. This is the adjacent side. Therefore, I want to use something with opposite and adjacent. That's tangent. So we are using this. So tangent of this is this over this. In an equation, that's tangent of 41 degrees is equal to x, the thing we don't know, divided by 350 feet. To solve for x, the height of the building, I can multiply both sides by 350. On the right, 350s cancel perfectly to give us just what we're looking for, x. And the rest, 350 times tangent of 41 degrees is, again, something I can just get from my calculator. I'm going to do that. Let's see, 350 times tangent of 41. Okay, rounded to the nearest whole number, that is 304 is equal to x. So the height of the building is 304 feet, approximately, because here we rounded. Now, just if you're curious, I'd like to address a couple of things. First, back in example number 1, we were given this triangle and we solved for the measure a. If you remember, we figured out that sine, which was this divided by this, or 0.8, set up this equation. And I said, oh, the way I figured out the angle A was by guessing numbers until I got something close to this. There's actually an equation built in your calculator, so you don't have to do this guess and check approach. And it's sine with this -1, meaning inverse, sine inverse exponent. Here, if you type in sine inverse of 0.8, which I'll try right now, sine inverse of 0.8, it gives me 53.13, which is even better than the guess I was using to give some more accurate measure of this angle. A calculator should be able to be programmed so you don't have to guess and check. You can just type in a number that you want and you get your answer from it. This idea here is actually quite complicated and has a lot of subtle details and a lot of different cases to consider, which is why we're not really looking at it in this class. If you were to take a trigonometry course, you would really get into the details of how this works. The second thing I'd like to address is, in your calculator, how are sine, cosine, and tangent computed? Why can't you just put a number in place of sine and it always gives you this number on the other side? How does that happen? This is done by using polynomials. And if you've encountered these before, the idea of a polynomial is you have a variable, like x. You can raise it to an integer exponent, like maybe x to the fourth, or I'll put x cubed, maybe x. And you can multiply these variables to powers by numbers. Like maybe here you're multiplying by 2, and this one you're multiplying by a fourth, and this one is 7. A polynomial is these types of objects that are added or subtracted from one another. And you can even have a number at the end, like something like 4. So variables to integer exponents multiplied by fractions or whole numbers, added or subtracted together. Polynomials are fantastic for computing numbers in a calculator. And the reason why, if you put a number in place of x, any number that you want, like maybe you're going to let x equal 0.31. If you put that number into here, a computer can instantly calculate the value of that expression. And that's because this thing depends on only 4 basic operations. There's addition, subtraction, multiplication, and division. Here there's addition. Here there's subtraction. Powers is repeated multiplication. And occasionally you have to divide by a number. You can easily program a computer or a calculator to do these operations extremely quickly. And that's all a polynomial is. It is some combination of these operations. So I'm going to enter this expression into my calculator, and I'm going to type in 0.31, and I'm going to see how instantly it gives me an answer. Okay, I just typed in this polynomial expression, and I'm putting in 0.31, and I'm about to hit enter, and it just instantly gave me that the value of this expression becomes 1.8559, and it was immediate. So it can go from here to here extremely quickly. Again, the idea is if you have a polynomial, they work great in computers and calculators because they're just doing these operations and they can do them fast. How does that relate to sine of any number x you decide to put into it? Well, it turns out that this thing can be represented by a polynomial. Technically, what is known as an infinite polynomial. Here's what that looks like. It's equal to x minus x cubed over 6 plus x to the 5th over 120 minus x to the 7th over 5040 plus x to the 9th divided by 362,880. And this thing goes on forever, and I'll put that by a dot, dot, dot. So sine is actually the same thing as this infinite polynomial. But if you go out far enough, that's enough to get a very good estimate for the values of sine. So what's programmed into a calculator is a polynomial, but you go out far enough in that polynomial so you get a very accurate answer. So when we put something like 53.14 into this, it's really going into this thing, and your calculator can compute this very quickly. It's just using addition, subtraction, multiplication, and division. Now, the more complicated question is, okay, it's a polynomial, but where does this thing come from? That is a very difficult question to answer. But if you were to take a calculus sequence, by the end of the first year, you actually come up with a way to prove that sine is equal to this thing here. So again, that is beyond the scope of the course, but it is good to know that when you're typing these numbers into a calculator, they're coming from formulas and ones that your calculator or computer can compute quickly.